researchers and resources to community issues that focus on human environment geographies. So we already have some students working on pilot projects. Next month, we're going to announce our first funding opportunities and workshops, and you can learn all about it via our website, which I am showing you here. And you can see the web address there on the left side, communitygeography.unm.edu. If you are here because you have some interest in collaborating with us at UNM, please get in touch with us. My email address is at the bottom right there, and you can also drop something into the chat during tonight's session, and I'll be happy to respond to you. So I already see some familiar faces out there, but also a lot of new ones, and I'm excited to meet people. So before we get started, I want to acknowledge first that we are hosting this from the University of New Mexico, which sits on the traditional homelands of the Pueblo of Sandia. The original peoples of New Mexico, Pueblo, Navajo, and Apache, since time immemorial, have deep connections to the land and have made significant contributions to the broader community statewide. We honor the land itself and those who remain stewards of this land throughout the generations, and we also acknowledge our committed relationship to Indigenous peoples. We gratefully recognize our history, and we invite you all to join us in that recognition. So I'm now going to hand it off to our Associate Director, Miriam Gayantaki. Miriam is new to UNM. She just arrived this summer in the middle of the pandemic, but she's already hit the ground running. She researches climate change, politics, and policy, focusing on global dynamics of who gets included and excluded from the conversation. So we're really glad to have her on board. And Miriam, I'm going to turn it over to you to introduce our speaker.
Thank you so much, Maria. I am thrilled to introduce Dr. Jamie McEvoy, Associate Professor of Geography at Montana State University. She earned her PhD in geography from the University of Arizona, where we met and became friends and colleagues. I'm very excited to hear your talk today. Dr. McEvoy is a human environment geographer with expertise in political ecology, water governance, and climate change vulnerability and adaptation. Throughout Dr. McEvoy's career, she has conducted research on perceptions of water quality associated with oil and gas development in eastern Montana, on public participation in water planning along the Yellowstone River, on the impacts of desalination in northwestern Mexico, and on the feminization of agriculture in southwestern Mexico. She has published widely for diverse audiences, ranging from top-ranking academic journals, such as the Annals of the Association of American Geographers, to sharing her work with water planners in the Montana Department of Natural Resources and Conservation. Her recent research focuses on how individuals and communities prepare for droughts and floods. In addition, Dr. McEvoy received a prestigious Fulbright Award last year to conduct research in Mexico and Canada, to work on cross-national comparative case studies to learn more about barriers and opportunities for natural water storage as a climate change adaptation strategy. Unfortunately, she was unable to pursue this work due to COVID, but we're hopeful that she can be able to undertake this research soon, this year, hopefully. So the Mallory Center for Community Geography is delighted to host you, Jamie, as our first speaker. We look forward to your talk on drought, planning, and adaptation alongside communities in southwestern Montana. And now, everyone, please join me in giving Dr. Jamie McEvoy a warm welcome. So take it away, Jamie.
Okay. Let's see. So hopefully, are you seeing the correct screen? Okay. Well, first, thank you for that introduction, and thanks so much for the invitation. It's an honor to be invited to give a talk for the R.H. Mallory Center for Community Geography. And thanks Dr. Maria Lane and Dr. Miriam Gayantaki for inviting me, and others who helped to organize the event. And thanks to you all for tuning in this evening. As Miriam said, I'm an associate professor of geography at Montana State University in Bozeman, Montana, where I live and work as an uninvited guest in the indigenous territory of the Valley of the Flowers, which has been and remains a place of learning and gathering for American Indians. So there's no one particular tribe in this region, but it's a gathering place for many American Indians, past and present. Tonight, I'll be talking about my research on drought planning and adaptation, which examines the effect of drought not just on people and human communities, but also on ecosystems and natural communities. And as Miriam mentioned, as a human environment geographer, we're really interested in those feedbacks between both human and natural systems. And in this case, when it comes to drought impacts and drought preparedness. So I'll start with this image from a recent paper that shows the simulated change in the date of snowpack disappearance under 1 degree of warming. And the area of dark gray and pink, so for example, if you can see my cursor here, this is showing where snowpack melt dates are changing more rapidly and where snowpack is disappearing earlier. So a takeaway message is that the coastal regions, the Arctic, and the US West, especially the southwestern US, is most at risk for premature melt. So while earlier spring snowmelt is a big concern here in Montana, I imagine it's something that you all in New Mexico are also concerned about. So in my case study, I'll be talking about some ways of viewing drought, and in particular, this issue with earlier snowmelt runoff, as well as a couple of adaptation strategies. So diving into my study region, I'd like to take you all to the Upper Missouri Headwaters Basin in southwestern Montana. This region is often referred to as the headwaters of the headwaters because it is where the mighty Missouri River begins at the confluence of the Madison, the Gallatin, and the Jefferson rivers. And I'd like to show you 4 graphs that summarize the key climate change impacts in this region. So first is this graph, which shows temperatures. Temperatures are expected to rise, so there's a clear warming trend. Second, when it comes to precipitation, the projections are more mixed. Scenario trends vary from somewhat wetter to somewhat drier, but most scenarios depict a nominal wetting trend, but this may be more variable over time. And third, this graph shows snowpack and the average snow water equivalent in the watershed in the Upper Missouri Headwaters. And warmer temperatures are impacting snow accumulation in the mountains, and we're seeing declining snowpacks. And finally, and this is the graph that's really most important for my research and what I think is grabbing a lot of people's attention. And this graph is showing the change in the timing of peak stream discharge. And so in Montana, as in other snow melt-driven watersheds, snowpack is a vital source of spring runoff. And the timing of that runoff is really important. Both human systems and ecosystems have adapted to this timing. And as predicted by Evan and Eisenman, who were the authors of the article, that first picture that I showed with earlier snowmelt, we're seeing that here. The peak runoff is shifting from the traditional June-July time period. So shown in blue, this is the traditional historic period. And we're seeing this shift, this earlier peak flow shift to more like April, May, as shown in orange. And so that translates to decreased water availability throughout the rest of the summer and fall. And this has huge implications for agriculturalists whose water rights are tied to a specific period of use. And it also has impacts on aquatic ecosystems. So our snowpack is often referred to as a water tower, a form of storage. And as Philip Mote and his colleagues have noted, snow provides crucial storage of winter precipitation and effectively transfers it from the relatively wet winter to the typically dry summer. But with the decline in snowpack and earlier snowmelt runoff, stream flows in late summer are reduced. And so here we see an image of from the 2016 fish kill that happened on the Yellowstone River outside of Yellowstone National Park. And these are several whitefish, and thousands of whitefish were killed in this event. And it was technically from a parasite, but fish biologists acknowledged that the high water temperatures and the low water levels made the fish more vulnerable to this parasite attack. So when this fish kill event occurred, officials had to shut down 183 miles of the iconic Yellowstone River to fishing and recreation, which caused a loss of revenue in the tourism and fishing industry. And it also sparked some pretty intense arguments between different stakeholders about who was to blame. And many people ended up pointing fingers at agriculturalists for diverting water during a time of low flow. So it also sparked interest in thinking about ways to prepare for and mitigate drought, with a goal of ensuring late summer stream flows for both agriculture and fisheries, for both human and non-human communities. So in response to the growing interest in drought impacts and drought preparedness in Montana, I was invited to be part of an interdisciplinary working group focused on drought, and with a special focus on the ecological impacts of drought. And this was a collaborative effort supported by several organizations listed here, including the U.S. Geological Survey's National Climate Change and Wildlife Science Center. And the director of that center is Sean Carter, shown here in the red shirt. And he is particularly interested in gaining a better understanding of the impacts of drought on ecosystems. But our working group included hydrologists, climatologists, wildlife and fisheries managers, folks from the National Drought Mitigation Center, and 3 academic social scientists, including Dr. Nejm Rahim. I point him out because he did his PhD at the University of New Mexico. I don't know if anyone would know him. He looked at the acequia system in New Mexico. And myself as a human environment geographer. And then I'd also like to shout out for my social science colleague, Amanda Cravens, here on the right. She has a master's in geography and then a PhD in interdisciplinary social science. And she now works for the US Geological Survey, which turns out, I never knew, but the USGS has a small social science research branch. So it's been really interesting to work with Amanda and learn more about the social science work done under the auspices of the US Geological Survey. But as social scientists, and with 2 of us having backgrounds in geography, I would like to think that what we've brought to this group is a way of helping the group to think about ways that human activities contribute to drought conditions, but also how human communities and human values are affected by drought. And then, of course, the feedbacks between human and natural systems. So one of the first things our working group did was develop a definition for ecological drought and develop a framework for thinking about ecological drought. So prior to being involved in this research, I didn't actually know that there are so many different ways of defining drought. Sometimes people define drought by their drivers. So you might hear of a meteorological drought, which would be, lack of rainfall. But sometimes people define a drought in terms of its impacts. So you might hear of an agricultural drought or a socioeconomic drought. But previously, there had been no formal definition for an ecological drought. So we defined it as an episodic deficit in water availability that drives ecosystems beyond thresholds of vulnerability, impacts ecosystem services, and triggers feedbacks in natural and/or human systems. We also developed this framework, this vulnerability framework, to think about key drivers of drought. So on the left up here in yellow, we have the meteorological and physical conditions. But on the right, we also included human factors such as human land use and human water use as drivers that affect ecologically available water. This also shows how both human and natural communities can be impacted by drought, but then also how responses in either ecosystems or human systems can affect the system's vulnerability, either increase the vulnerability or decrease vulnerability. I want to recognize Dr. Anne Van Loons, who I'll provide at the end of my talk a list of papers that I mentioned, but we drew heavily on work by Dr. Anne Van Loon and her paper on drought in the Anthropocene. And she and her colleagues basically argue that we can no longer think of drought as purely natural hazards. Geographers will know this well when we think about what's the natural part of natural hazards. But she argues that we must rethink the concept of drought to include the human role in mitigating and enhancing drought. So our next step as a team was to test out this vulnerability framework that we had developed. And we decided to test it out in the Upper Missouri Headwaters region. And this region was selected as a case study site for two reasons. First, the region has well-known blue ribbon trout fisheries. It's known for hunting and recreation. So we had a hunch that drought was maybe defined differently here in more of an ecological sense. And we also selected it because since 2014, or beginning in 2014, as part of the President Obama's Climate Action Plan, the administration had designated the Upper Missouri Headwaters region as a pilot project for this National Drought Resiliency Partnership demonstration project. So you may hear me refer to NDRP. I'll try not to use acronyms too much, but NDRP is this National Drought Resiliency Partnership for which there was a pilot project, one of two pilot projects that was based in the Upper Missouri Headwaters. And the goal of this partnership was to bring together information and resources. So this included data, tools, funding, and then partnerships between various federal, state, and local agencies with the goal of improving drought planning capacity and building capacity at the local watershed level to increase the resiliency to drought. And on this slide of alphabet soup, I know it's a lot of acronyms, but it's basically showing the wide range of partners involved in this National Drought Resiliency Partnership. It includes various federal, state, regional, and local organizations. So this project was ongoing, but as researchers, we wanted to collaborate and sort of dovetail along with this project and see where we could help and provide additional information. And we also used this ongoing project to better understand how people plan for and adapt to drought. So as researchers, we used the list of partners here as our sample frame. We collected a variety of resource planning documents, so like drought plans and other resource plans that these different groups produce. We held a one-day ecosystem services workshop, and we conducted 44 interviews with representatives from these various organizations. And given the interdisciplinary nature of our working group, we jointly developed the interview protocol, and each of the 44 interviews was conducted by one social scientist and one ecologist. And that was new for me. I'd never done that before. It definitely took extra time, but I think in the end, the ecologist brought up questions we wouldn't have thought to ask, and vice versa. So in our research and what I'll be talking to you about this evening, we wanted to learn, how do participants understand drought? And this is what we term their drought orientation. I'll talk about that in a minute. We also wanted to understand if there were any innovative ways of preparing for drought. So first, in terms of understanding how participants understand the challenge of drought. This is an image showing, I'll walk you through it, but it's basically saying, okay, we know drought affects both natural and human communities, but how do the participants, how do the managers and stakeholders view drought? Are they seeing drought as something that affects both natural and human communities, or are they just seeing part of the problem? So my colleague Amanda came up with what she calls the Eye of Sauron figure, where if you're a type 1 drought orientation, if that's your orientation, you might only see the impacts on the natural system, versus a type 2 drought orientation would see the human impacts. And what we argue is that, a more integrated, holistic approach is someone who would be able to see both impacts happening and plan for that. So what did we find? How did participants understand the challenge of drought? What was their drought orientation? And this next slide, there's a lot to it, but I'll walk you through it one at a time. So to answer the question, we analyzed our interviews. We analyzed them to see how interviewees described their professional role as it relates to drought, how they defined drought when we asked a specific question, and then how they defined, and then the types of impacts they talked about in terms of being the impacts that they manage for or the impacts that are of most concern. So starting with their professional role, we found that despite job titles, which might suggest a more human-centric approach or a more eco-centric type job, that actually the majority of our interviewees described their role in drought preparedness in a more integrated fashion, mentioning things related to water for people and water for ecosystems. So in the figure here, each bar represents an interview. So we had 44 interviews, and it's color-coded based on how interviewees described their role. So the bar is yellow for an interviewee who described their role as being solely focused on ecosystems. Blue for those who are solely focused on people in terms of their role description. And green, the vast majority, 36 out of the 44 interviewees, described their role as having to do with both ecosystems and people. So mostly folks had a pretty integrated way of thinking about their job role. Next, we looked at how interviewees defined drought. Specifically, we asked the question, what is your definition of drought in the Montana context? And we coded just their response to this question to see if their definition of drought focused on drivers or impacts. And at the top here in black text, we see 3 of our interviewees mentioned drivers only. The rest mentioned, 30 of them mentioned both drivers and impacts, and 11 mentioned just impacts. So then we looked at the 41 interviews that mentioned impacts, and we looked at whether the impacts were human uses of water or related to ecosystems. And we see that 23 of those 41 interviews described impacts related to both people and ecosystems in their definition. And again, that's at the top text. So then the last thing we did was we analyzed the type and frequency of drought impacts mentioned throughout the hour-long interview. So not just in their definition of drought, but what they talked about in terms of what they were managing for, what their priorities were, and what their biggest concerns were. And what we see here, well, first of all, there were over 100 distinct impacts of drought that were identified across the 44 interviews. We then classified those impacts as either ecological or not. And in the figure, what you're seeing is the proportion of the bar that is shaded versus unshaded shows the percentage of impacts mentioned that were either ecological or not. So interviewees on the left-hand side had more mentions of ecological impacts, whereas interviewees on this right-hand side had fewer mentions of ecological impacts and more mentions of non-ecological or human impacts. And so we used this information to assign the interviewees a drought orientation. So over here, we have our type 1, or sort of people who are focused on the ecosystem impacts. Over here, our type 2, people who are focused just on the human impacts. And in the middle, we found that just 25% of our interviewees, or just 9 people, had a more balanced mention of impacts that they were concerned about, mentioning a closer to equal number of ecological and non-ecological impacts. And I would note that for those not in the middle here, people who had more siloed views tended to mention twice as many impacts, so twice as many non-ecological impacts as human impacts, or vice versa. So it was a pretty different, when we narrowed down to what they were managing and focused on, it was really different than the way they described their role or their original definition of drought. And so we take that to mean that it's probably in part related to a time and logistics on a day-to-day basis. While you might understand drought more broadly, you have to narrow in and focus in your daily activities on a smaller range of items. We compared the drought orientation with job type, and we found that almost all of the interviewees who worked at the local watershed scale, so it was 8 out of 9 of our local level interviewees, had more of a human focused type 2 drought orientation. So we think that that suggests that for folks working at the local level, they probably need to be paying more attention to specific community and economic needs of water. In contrast, 14 of the 20, so more than half of those who worked at the federal level, had an ecological type 1 orientation. And many of the non-governmental organizations, the environmental nonprofits that we interviewed, also had more ecologically focused type 1 orientations. And participants who worked at the state level had a mix of type 1, 2, and 3 drought orientations. So what? What do we take away from this? Why does drought orientation matter? Well, we argue that understanding drought requires understanding the perceptions and problem definitions of the different stakeholders who are tasked with monitoring, preparing for, and responding to drought. And we found that despite the integrated nature of the interviewees' definitions and description of their roles, when it came to the impacts of most concern and what they managed for, their perspectives were more siloed. And so we think that this maybe reflects some institutional constraints, that while an individual, as I mentioned, might have a broader understanding of drought, that in their day-to-day operations, they need to narrow their scope. Also, we think that this suggests that an interagency or interjurisdictional effort, like the National Drought Resiliency Partnership, could be helpful for helping partners work across roles and accomplish goals that transcend any single individual's focus or any single agency's mandate. And again, I would emphasize that human environment geographers are well positioned to help bridge this gap and promote a more integrated understanding of drought and a more integrated approach to drought preparedness. Another way we went about trying to understand how the problem of drought in the Upper Missouri Headwaters is understood was by analyzing watershed drought plans. And specifically, we analyzed the content of the 5 watershed drought plans listed here. These range from a very early 1988 plan to avoid dewatering of the Ruby River to a more recent 2016 Beaver Head Watershed Drought Resiliency Plan. If you're familiar with this region, you might keenly be noticing that the Blackfoot River is not part of the Upper Missouri Headwaters, and you are right to notice that. It's not part of the basin, but it's held up by a lot of state planners, state water planners, as a really great example of a drought response plan. And so we wanted to look at it to see what's included. And so we read through these plans and we coded them for any mention of drought impact as well as indicator. And the indicator, it turns out, is really important. Our collaborators at the National Drought Mitigation Center really emphasize that in drought planning, it's not enough just to talk about it. You have to have an indicator so that you can measure and monitor that impact. So our findings show that ecological impacts are taken into account. So that's good news. You know, there is some awareness of the fact that drought affects ecosystems. However, it's through a fairly narrow lens of impacts to fish populations and fisheries. We can compare that to this quote from our interviews from a local watershed coordinator who says, when people say the health of the river, what they really mean is the health of the fisheries in the river. It's a fairly narrow ecological view. And that pretty much sums up our findings of this drought plan analysis. But just to walk you through our full analysis, what we did was every time an ecological impact was mentioned in the plan, we ranked it on a scale of 1 to 3. So if it was just mentioned, it was given a 1. If it was mentioned and discussed in some level of detail, it was given a 2. And if the plan actually included an indicator that could be used to measure and monitor that particular impact, it was given a 3. And as shown here, impacts to fish and fisheries were the only item that were ranked as a 3. So other impacts such as increased forest fires or effects on rangeland productivity or wildlife mortality were mentioned and sometimes discussed in some level of detail. These other impacts were never associated with an indicator, which are, again, our friends at the National Drought Mitigation say that's not enough. Yeah, you really should have an indicator. And there were indicators again for stream flow, but these relied primarily on stream flow and water temperature to understand the impacts to fish. But in our interviews, several people noted that there are other indicators that they either use or often in many cases things they would like to use but don't currently use. And these include soil moisture. So there's a big push to increase the soil moisture monitoring network across the state. People also mentioned using normalized difference vegetation index and the evaporative demand drought index as other indicators that could be used. All right, so I'll turn to the second part of our research objective, which was to identify innovative ways to prepare for drought. And I'll briefly discuss shared sacrifice, and then I'll spend the rest of my time talking about beaver mimicry. So shared sacrifice refers to a voluntary and cooperative agreement among willing irrigators that when a certain low flow threshold is reached, they will all agree to cut back their water diversions. And technically this is illegal. It's outside the legal framework. I call it extra legal, meaning it's an extra legal workaround what is an otherwise perverse prior appropriations legal doctrine that tells water rights holders that if they don't use the water, they're at risk of losing it. And I'm sure you've heard this phrase, that use it or lose it. And it's interesting because our state water agency is very much promoting this idea of shared sacrifice, but it is technically, they're also the agency that oversees water rights. And, you know, technically, if you were to abandon your use for a long period of time, like 10 to 15 years, you could be at risk for losing it. But this idea of use it or lose it, I think does scare some water rights holders that you know, is it okay in a single season to not use my full allocation? But in these plans, so in the drought plans that we looked at, the shared sacrifice agreement is in effect, and it's really the basis for most of the plans that we looked at. In addition, so these are primarily voluntary agreements, but in some watersheds, there are endangered species. For example, in the Big Hole Basin, the Arctic grayling is at risk of becoming listed as an endangered species. So in this case, there is a formal and legal agreement that can be used to bring irrigators to the table to work with state agencies to establish a water conservation plan that's called a candidate conservation agreement with assurances. And this plan ensures that if the water user agrees to make voluntary changes to their water use and land management practices as specified in this plan, that if despite their best efforts, the grayling still were to become listed as an endangered species, that the landowner would not be on the hook for taking any further legal action. They wouldn't have to further adjust their land or water management practices because they tried to do something before. So the benefits to the ecosystem is hopefully maintaining minimum flows for fisheries, and humans benefit by avoiding conflicts between irrigators, fishing guides, and recreationalists, and in some cases, avoiding an endangered species listing. All right, the second innovative strategy is one that was mentioned in our interviews, and that's beaver mimicry. The figure on the left is from a famous kind of beaver handbook by Michael Pollock and his colleagues, and it shows a generalized process of how beaver dams or beaver dam analogs, so that would be beaver dams built by people, like in this picture, can restore an incised stream by raising the stream bed to reconnect the stream with the floodplain. And when the stream is reconnected with the floodplain, it allows the spring flows to be captured in the floodplain, and that recharge can help recharge the aquifer. And under the right conditions, that recharge can then provide late summer stream flows, which are also called return flows to the stream. So in Montana, there has been a real interest in beaver mimicry. And it was mentioned in the state water plan in 2015 as a potential strategy for buffering against both flood and drought. And you'll remember back to that first picture I showed that showed the timing of the change in snowmelt and the change in runoff. And what that's suggesting is that because we're losing that storage in our snowpack, a lot of, everyone's sort of saying we need more storage, but the question is, what is that form of storage going to take? So there's concern that there could be new calls for more dams, and by dam, like concrete traditional dams to be built, and high elevation dams. So currently places where we don't have dams, there might be calls to build dams in high elevation areas. So beaver mimicry offers perhaps an alternative and a more environmentally friendly alternative to large dam construction. But there's sort of a growing rift between restoration practitioners, people who make a living restoring streams, and in particular using this method to restore streams, and academic scientists over the purported claims about the benefits of beaver mimicry. So beaver believers, as I call them endearingly, beaver believers argue that there are a myriad of benefits, including increased surface and groundwater storage, elevated riparian water tables, increased water availability in the late summer, flood protection, improved water quality, increased channel stability, and improved fish habitat. But scientists are wondering how certain we are about these benefits. A recent paper by Caroline Nash at Boise State University and her colleagues, they outline what they call the various process pathways and point out, there's a lot of complexity and biological uncertainty. If you do X, will you really get Y, or does it depend on several other intermediary steps occurring as well? But I'm more of a social scientist. I'm a human environment geographer, but my methods are in the social sciences. And so what do I have to add to the conversation about beaver mimicry? Because a lot of this is about hydrological questions. Do we understand how the hydrology works? So in the last 15 minutes of my talk, I'll be describing how, as social scientists, we went about trying to understand different stakeholder views on beaver mimicry, and help to shed some light on these debates between hydrologists, practitioners, and also landowners. And the results that I'll present here are from a different study, still related to drought planning and adaptation, also with my colleague Amanda Cravens, but with some other colleagues at the USGS, along with my former graduate student, Megan Moore. And in this study, we looked at two different sets of interviews, different even from the interviews I was describing earlier. And these were interviews with 49 individuals who were asked specifically about their perspectives on beaver mimicry. And again, these included scientists, practitioners, and landowners. And to make sense of the different perspectives that we were hearing about beaver mimicry, we used this framework by David Cash and colleagues on saliency, credibility, and legitimacy to understand how different stakeholders were evaluating information, and specifically how they were evaluating information in terms of its salience or relevance to the decision context, in terms of its credibility, that is the information and evidence produced by sources who are perceived to be authoritative, and then lastly, legitimacy, which is the information and evidence created through a process that is perceived to be fair and unbiased. And then following a previous study that my colleague Amanda had done, we use this framework to understand salience, credibility, and legitimacy, not just as criteria, but actually as a process, and a process that is negotiated between different stakeholders to determine what information is valid and what information is not valid. So we analyzed our interviews, and we saw that there were three main sticking points or areas of disagreement where we saw contested claims and unsettled science. So the first was around ecological outcomes. As I've already described, restoration practitioners make a myriad of claims about lots of different environmental benefits. And in all of our interviews, all groups, scientists, practitioners, and landowners all agreed that there are likely potential ecological benefits. However, 40% of the scientists expressed concern about the certainty of these ecological claims, especially concerns about fish passage. Can fish get through these structures? And then also the effects on stream flows. As one scientist said, the goals related to stream flow end up being a lot murkier and a lot less likely to happen. 17% of the practitioners also expressed uncertainty about the scientific basis for some of the ecological outcomes, but they were a lot less concerned. They didn't see that as a barrier. They didn't feel like they needed to stop implementation of these until we had this nailed down on a scientific basis. The second sticking point for beaver mimicry was regulatory uncertainty. And here it's not so much a debate between the different stakeholders, but it's just an area of unsettled political science. The majority of interviewees across all three groups viewed the lack of clarity about the rules and regulations surrounding beaver mimicry as a significant barrier. Namely, there were concerns about if or how beaver mimicry structures affect water rights. And landowners in particular expressed concern for impacts to their own operations or to their neighbors through water loss or damage. And as one landowner said, and himself being a rancher, ranchers, if somebody starts doing something like this, they're going to say, hey, you're taking my water. And also related to this regulatory uncertainty, scientists and practitioners said that they avoid using the term dam when discussing beaver mimicry with regulatory agencies. As one practitioner said, as soon as you say the dam, that triggers a vision in our state water rights agency of something that's impounding water, which would trigger a water right. The third sticking point has to do with different views on the cost and ease of beaver mimicry. So practitioners and scientists discussed the ease of implementation in a relative sense. For them, it was easier and cheaper than other ways of going about stream restoration, which typically require the use of large machinery to reshape river channels. In contrast, beaver mimicry makes use of locally found willow branches and mud. And so as one scientist said, the low tech, low cost thing is appealing and therefore more likely to scale up and be able to affect larger landscapes. So even though scientists and practitioners referred to these as low cost, they did note a lack of funding, especially for ongoing monitoring. And they felt that if they were really going to advance this field, there needed to be more monitoring information and more monitoring data. In contrast, landowners had very different views about beaver mimicry costs and ease of implementation. Many landowners flat out disagreed that these structures were cost effective. They were thinking about the cost of having to personally pay for the structure and also to maintain them, which requires money, time, and labor. And additionally, these structures might require taking land out of production. So as one landowner said, I think it would be a nice hobby, and I think the results are probably desirable, but I don't have the time and money to even think about it. So we have these three sets of areas of contested claims, and to make sense of what we were hearing, we used the Cash et al. Framework to understand how different stakeholders evaluate salience, credibility, and legitimacy of the information and evidence related to beaver mimicry. So we'll start with scientists, and we found that scientists considered information to be salient if it was relevant to implementing or evaluating a project. As one wildlife biologist said, managers want to know, what should I do here, when, why, and how? And scientists want to be able to provide that information. But most important for scientists was the credibility of information. I'm sure this won't surprise you. For scientists, information is credible when it meets the standards of the scientific process, uses the scientific method, and is published in the scientific literature after a formal peer review process. Scientists emphasize the importance of long-term monitoring and evaluation to reduce uncertainty and establish a more legitimate evidence base for beaver mimicry. And in terms of legitimacy, for scientists, credibility and legitimacy were linked. And unsurprisingly, information was considered legitimate if, again, it was the result of a structured data collection and analysis based in the scientific method and subject to peer review. So as one scientist said, we're trying not to be a bunch of condescending ivory tower scientists. There's quite a bit of enthusiasm around beaver mimicry and restoration. And I think when you step back, it's a good tool, but it's not going to get you where you need to go. And he went on with to paint a more cautionary tale, saying we might find out later that by not doing the research first, we actually caused more problems. All right, so now taking a look at practitioners and how they evaluated the evidence. And first to note, the category we call practitioners includes resource managers, employees of environmental nonprofits, and stream restoration professionals. And this group drew on a range of knowledge types to answer questions about beaver mimicry. And this knowledge includes experiential knowledge, anecdotal evidence, and I use the term anecdotal because that's the term they use. I know that when we talk about Indigenous ways of knowing, that the term anecdotal can be very offensive. So I want to note that the term anecdotal was the wording used by our interviewees. And then they also used scientific evidence. So given the applied role of practitioners in project design and implementation, the salience or relevance of information was key. But it's interesting, they considered information to be salient when it was relevant to achieving the desired goals of the project. Compared to scientists, practitioners viewed credibility on a much wider spectrum. They valued experience more than experiments. As one contractor explained, we anecdotally can see this making the landscape better than it used to be. Therefore, why do we need to do this monitoring to answer this question? This experiential way of knowing was considered credible by many of the practitioners, and so many practitioners agreed that that's all the type of evidence that we need. But other practitioners agreed more with scientists and said, we do need more field data. But in general, even if they felt like they needed more data, they weren't nearly as concerned or worried about proceeding with the project before they had that data. And in contrast to scientists, practitioners did not appear to have an objective standard to determine information legitimacy. Rather, they acknowledged explicitly that information about beaver mimicry is influenced by social and professional values and priorities regarding natural resource management and restoration. And in fact, information was considered legitimate when it aligned with the specific values and desired outcomes of the people they were working with to design a beaver mimicry project. The practitioners emphasized that the enthusiasm for beaver mimicry and the implementation was far ahead of both the science and the regulatory framework. And they, as this practitioner argues, that the field of restoration has undergone what he called a cultural shift that he thinks science and the regulatory community has not gone through. So just to read you this quote, he says, "We are talking about trying to get people through a cultural change. The culture is really just the socially constructed perception of what the stream looks like, or what the stream should look like. The beavers have been gone for so long that we have our value system and our vision of what a stream should look like and how streams function and the role that this rodent plays in all of that." So what I understand him to be saying is that in the stream restoration community, they've come to realize what streams used to look like with the presence of beaver, and now they're trying to get others to see that as well. All right, so lastly, moving on to our landowners, we found that landowners relied on local agencies and organizations such as local conservation districts or local watershed committees. They also relied on evidence gathered from community members who had personal experience with beaver mimicry. Landowners considered information relevant or salient if it provided them with information about the costs and benefits of implementing the project on their property. Landowners needed to strike a balance between achieving socioeconomic benefits with environmental benefits. So several landowners mentioned being able to charge for fishing access on their property as an incentive for why they would do this project. For landowners, credibility and legitimacy were closely linked. Landowners evaluated the credibility of information based on the trustworthiness or legitimacy of the source of the information. And trust was established through personal relationships and personal experiences with certain groups. Only 2 landowners mentioned the lack of scientific data as a concern. Instead, they were more concerned about the legitimacy of the process and how the project had come to be. They viewed projects as legitimate if it promoted landowners' autonomy over their land, and they were concerned if the project seemed to be pushing someone else's agenda onto their property. So again, the most important information for landowners was the cost and benefits of the project. As this landowner said, for a rancher, first he's got to see that it will not be detrimental to him. Second, he's going to have to see some economic benefit. And landowners had a strong preference for information that came from a local and trusted source. As this landowner said, the nice thing about people in our ranching industry is that they do like to go visit neighbors and look around. If something works and really has value, I think the word gets out. So again, the so what point here. We take beaver mimicry, we understand beaver mimicry as just one of several types of contested environmental practices. So it represents not only a case of scientific and unregulatory uncertainty, but also a meeting point between different communities that hold different values. And at such a meeting point, understanding salience, credibility, and legitimacy and how those get negotiated is important. But also that in that negotiation represents a deeper negotiation over the validity of different ways of knowing. So while it may not be possible or productive to try and convince others of a particular epistemological approach, we argue that at least recognizing how different communities evaluate evidence can lead to a better understanding of the conflict, which in turn can lead to perhaps new and different approaches to addressing the conflict. So with that, I'll end with my final slide, which is just a plug again for geography and the importance of a geographical perspective on drought planning and adaptation. Geographers being trained in an interdisciplinary way of looking at issues, we bring in integrated understanding of the drivers of drought, as well as an integrated view of drought impacts. And then lastly, we do analyses that are attuned to different priorities, values, and ways of knowing among diverse stakeholders. So I think hopefully we still have time for questions, and I can leave this slide up, which has a list of the papers that we've worked on, as well as several papers that I mentioned, and then my email contact if you would like to follow up with any questions that we don't address today.
Excellent. Thank you so much. Please help me in thanking Jamie for her talk. And I think what we will do, since I don't see like an order in how people will raise hands, is that we will use the chat to ask Jamie questions. And if you feel comfortable reading them out loud, when I call your name, please do so. So to ask Jamie questions, please do use the chat. And as we see, and if we have time, please do ask them yourself so there's more interaction with Jamie. And while people are using the chat to ask questions, I also want to let you know that Jamie McEvoy and Ben Warner, our own faculty in Geography and Environmental Studies, are going to be speaking in my class on April 8th at 4 p.m. You can go to our Center for Community Geography website for more information, where we will be reading papers from Jamie and Ben and discussing them, and more specifically discussing drought in the Southwest. So please do join us for that if you're interested, and go, there's more information on the website. So we're waiting here for some questions. Okay. Okay. Sarah, do you want to ask your question?
Sure, thanks. Hi, I'm Sarah Hurteau. I work for the Nature Conservancy here in New Mexico. I do a lot of the sort of practitioner work that you referenced in the Beaver Dam analog around the state. And I'm curious to understand from your perspective how we can strengthen the relationships between practitioners and academics, particularly when we don't have grant cycles that allow or oftentimes don't even pay for monitoring at all, let alone long-term monitoring to let the science sort of catch up with those of us that have to make decisions on the ground before the information is available. Thank you.
Yeah, fantastic. Thanks, Sarah. And yeah, the Nature Conservancy, as you likely know, is very active here in Montana. So I've worked a lot with Nate Korb with the Nature Conservancy. And I'll say, something, probably the reason beaver mimicry is on my radar is because of my first year at Montana State in 2013, Nate Korb organized an event on campus and basically brought together some of the key questions he had and brought in hydrologists and anyone else who was interested and sort of at least got it on our radar. So since that meeting, there's a hydrologist here, Rob Payne, who is doing some work understanding, how much water is actually infiltrated into the aquifer. There is an ecologist, Lindsay Albertson, who's now looking at how beaver mimicry affects aquatic systems. And then myself as a social scientist, many of these questions, especially regulatory questions that we've outlined. So I think just that, and it's a slow, so it's really more, it's just tricky because academic work is so slow, and I know it's frustrating. And I think that's what this really pointed out was, especially for folks in the field where they're seeing the benefits. And it also comes to this question of, what knowledge is valid and is experiential evidence enough? And I think really my critique is more to scientists. I'm not necessarily suggesting that the science isn't important, but that, scientists can't always be sounding the drum of science, that sometimes maybe we need to meet partway in the middle. But yeah, ultimately my sense is that it's very much just a need for more funding. So if we can just convince NSF and USDA and other agencies out there that this work is important and we need the funding and it's going to take time, I guess that would be my response to that question.
Thank you, Jamie. David Ritchie, do you want to ask the question yourself?
Yes, sure. I was just curious, since you used the division of the practitioners and the scientists and the landowners, how much of the land is actually private land that would be considered for beaver mimicry? And I'm guessing there's probably a lot of public land also. And is that yet another landowner group that has a little different orientation?
Yeah, that's a great question. Thanks, David. I don't have the statistics off the top of my head, but in general, it's much more state and federal land than private land. And yeah, the Forest Service has been doing some beaver mimicry on Forest Service land, the BLM as well. And so there are certainly lots of options outside of landowner property. And then actually something we're looking at here in the city of Bozeman, the canyon where the watershed, top of the watershed where our water supply comes from, used to have a dam, a small concrete dam. It broke years ago. The city technically has a right to rebuild that dam, but they know that in terms of the public perception, we're just not in a place now where building a dam or even rebuilding a dam that used to exist would really be acceptable. So the city's very interested in looking at the potential use of beaver mimicry, but again, they just need more evidence. So we're working on a proposal to do that, but again, I just think that having more data available to show if this works, does it store water? If so, how much? And then the public perception piece, if this is up a canyon in a very popular mountain biking recreation site, and we're creating suddenly kind of higher water tables, more wetland, is that going to create conflict with recreational users and things like that?
Thank you.
Maria, do you want to read your question?
Sure. Yeah. Thanks, Jamie, for this really interesting talk. I'm really interested in the way that your research is pointing toward really the most important thing in all of these attempts at doing different kinds of management is people's knowledge frameworks and their orientation. And I'm wondering if there's a way for assessing these things, the salience, credibility, legitimacy, and people's orientation more quickly than, sending out your team of researchers to do all these interviews. I mean, is there some kind of quicker, faster, more easily deployed method that a land manager or a city or county or state government could pull out of this and deploy more quickly?
Yeah, that is a great question. I am definitely going to have to think about it some more to come up with a good answer. But yeah, I mean, I guess just reflecting more generally, I'm trained as a qualitative social scientist. And so the method, again, is slow. It's based on interviews. It's not typically meant to be representative. It's meant to understand more nuanced aspects of any issue. But it's slow. So, a survey would be a little quicker. They're not totally quick, but yeah, I think you're asking a great question. Like, is there sort of a shorthand? I guess what I would say is maybe the takeaway from our research is just understanding that there are different perceptions. And I think that, just knowing that when you go in to do your work. So rather than being dismissive of, well, this person's not understanding, that I'm not saying, I'm saying there's not enough science and this person isn't understanding me. Well, it's not that for a lack of understanding, it's for having a different perspective. And so I guess maybe the shorthand would just be being aware, that those different perspectives are out there, if that helps.
Yeah, thank you. I agree. It seems really complicated.
Hi, Jamie. We have another question from David Ritchie. Do you want to ask that?
Sure, thanks. I was just curious about areas where you could actually introduce real beavers rather than mimicking them. Like here in Albuquerque, I noticed down along the Rio Grande in a very urban area, I see beavers working away all the time.
Yeah, that is a great question. So there's something out there called the BRAT, the Beaver Restoration something tool. The acronym spells BRAT. And then what that is looking for is it's using GIS data, remotely sensed data to understand vegetation and water, as looking for places where beaver could likely survive if they were introduced, or identifying a place where if you just maybe did some willow restoration, you could maybe attract beaver. So yeah, there's some great footage out there. If you Google like parachuting beavers in, you'll see, I think it was back in the 80s or so, they literally, put beavers in these parachutes, dropped them out of airplanes and just sort of let the beaver land and do their thing. They're no longer doing that, but there is a lot of interest in actual relocation of beavers. So I would point to the METHOW project in Washington, METHOW. They're doing a lot of actual relocation of beavers. And but I would also say that for landowners, the reintroduction of beaver is not always seen as beneficial because they can become a pest. So often for landowners, beavers are seen as a pest, so not always welcome. So in some ways, for some people, mimicking beaver is more preferable to actual reintroduction. And I see that Sarah maybe has a related comment or question.
Yeah, I know that here in New Mexico, we are, there's a study that was done, I think by Defenders of Wildlife, that did a similar GIS study for New Mexico about where the potential beaver habitat is. And there's groups like Trout Unlimited and the Nature Conservancy and Audubon and other like environmental nonprofits that are working on thinking about how we can work with game and fish to reintroduce beaver where it's appropriate and where landowners are amenable to the idea. So lots of policy work and relationship building to sort of pave the way for the reintroduction of an ecosystem engineer that is likely to have unintended consequences and their presence back in the ecosystem that maybe ranchers and landowners would not enjoy quite so much.
And Jim Shepard has a comment. Do you want to expand on that?
Okay, there's a lot of good work being done in terms of reintroduction. There's a lot of things that need to be done before you can put beaver out there. Actually building the BDAs and that ahead of time to get the habitat in better condition so the beaver will provide. And the work done on the Suzie Creek, Maggie Creek area in northern Nevada, Carol Evans and John Griggs found that actually by getting things started with the BDAs and improving the grazing plants, et cetera, to allow better habitat to form in these creek bottoms, then the beaver would come in, colonize, build dams, and they actually got much better water storage and that sort of thing going on.
Thanks. Those sound like some really interesting projects to look at. And this is where, again, kind of to Sarah's question, you know, I think part of it too is just capturing the existing studies and showing what is being done. And I'm sure there are people out there trying to do these synthesis reviews, but yeah, there is already quite a bit of work done showing the impacts in different places. So thanks, Jim. And maybe Sarah, did you have a follow-up?
I'll keep asking questions if everybody else is going to be quiet. Have you done any work in the work that you've been doing with BDAs, and particularly from the social science aspect, thinking about carbon sequestration and as an added benefit to the increased water storage capacity that is a result of the BDAs and other restoration techniques?
I have not, and that's a good one. So not specifically looking at carbon sequestration as part of beaver. I would say more broadly, when we talked about innovative drought management strategies, one of the ones I did not mention is a focus on soil health. So there have been a lot of workshops that were part of that National Drought Resiliency Partnership, talking about things people can do to improve soil health, to increase the water storing capacity of the soil. But interestingly, yeah, carbon sequestration wasn't necessarily mentioned, but yeah, maybe that's a good, also some way to maybe bring some funding in. My sense is there is some funding for soil carbon sequestration. So maybe getting those two things together under that umbrella.
There's just so much focus right now on, reducing the impacts of climate change through mitigation and adaptation. And this is an example project, which I think of why it's happening particularly so frequently here in New Mexico, where we have a scarcity of water, and is to increase the water holding potential higher up in the ecosystem to sort of mitigate that hydrologic shift that you're talking about with having the water come earlier in the season. And so these are the sorts of adaptation strategies that we're thinking about, but then the added benefit is that they also have a mitigation component of them because of the carbon storage capacity in wetlands is just off the charts high. And those ecosystems are so rare in New Mexico that it's sort of important. It's added it's being thought through more thoroughly to understand where we should be strategically restoring those kinds of habitats that might be vulnerable to climate change and therefore need this kind of armoring to increase their viability long-term under those climate impacts.
Yeah, I think that's great. And yeah, another thing to maybe add in as we continue to study, continue showing these multiple benefits. Absolutely. I'm going to stop sharing my screen just so I don't know if that would allow us to have more of a gallery view.
Jamie, I have a question. Thank you again for that. Wait, Michael at Sarah, do you want to take that question? Well, Michael, do you want to ask it? And Sarah, do you want to respond?
I can ask it.
Yes, go for it.
It's Michael Jensen. I'm with Conservation Voters New Mexico now, but I did a lot of river related work for a long time. So I just had a follow-up question to Sarah about doing the headwaters kind of works and potential conflicts with grazing allottees, because there are a lot of those lands up in the headwaters too.
Hi, Michael. Long time no see. It's good to hear your voice.
Yeah, you too.
Yeah, so we are working with landowners, particularly in private land and grazing allottees, to make sure that they, just as Jamie sort of conveyed in her work, that the framework in knowledge base and how people approach the field of restoration differently is important in how we reach out and talk to landowners. And if they're not interested, then we don't work there, so that we're not forcing them into a situation that is uncomfortable or that they don't agree with, or what. I mean, it's their land. And particularly working even on federal and state land where there are grazing leases, we work with the grazing allotment leasee to ensure that they're in the conversation about fencing and all of the other things that sort of come with these sort of restoration activities. So Trout Unlimited and Amigos Bravos, of course, have been partners in these sorts of projects in the past, where we've been working with landowners to ensure that sort of smooth sailing and agreement before we move forward with any kind of restoration activities. It's much easier when we own the grazing allotments too, so I'll just say that.
And on that, Jamie, could you elaborate a little bit more, having so many different stakeholders and contested narratives, what is it that you're communicating, or are you just collecting information? And who are you communicating, and what are you telling them?
Yeah, I would say so far, my grad student, Megan Moore, we combined her interview data with some other interview data for the information I presented on beaver mimicry, but she had just interviewed landowners in a particular watershed here in Southwest Montana. And yeah, it was more sort of asking them what they thought, not so much saying, here's a certain info. So she took like a brochure that said, here's a picture of beaver mimicry. Here are the kind of what people say about it. Would you be interested? Why or why not? And yeah, I think for me, again, as a social scientist, I don't know that I'm certainly don't feel like I'm going to be the one to have the final say on the hydrology of how it works or doesn't work, but more so for me, helping to facilitate that conversation, helping to understand the complexities. It's not, perhaps isn't just a question of, more science and beat ourselves over the head with more science, but understanding these different perspectives and different approaches, that no matter how much or how little science is there, things are going to be moving regardless. So let's maybe try and understand that landscape of values and priorities, which science isn't always the top priority as scientists, as we like to think.
Thank you, Jamie. And sorry, I skipped Jake Wolf. Do you want to ask your question?
Sure, and I think Sarah touched a bit on it with Trout Unlimited's help with the restoration projects, but I'm curious how the recreational fishing community values this type of work, since it seems like a lot of perceptions of river health are based on the health of the fisheries.
Yeah. So maybe backing up, not just beaver mimicry, but sort of kind of the broader context of drought planning, drought preparation. I would say here in Montana, very much so, the recreation community, I think, is on board. And I think Montana was interesting for our case study because, of course, other places like New Mexico, also have these values. But in Montana, increasingly, the recreation value is becoming so much more clear. Often even within the same family, someone who has for generations been in agriculture, perhaps the newest generation is making more of their living from guiding and fishing. And so I'd say it's certainly on the radar, and I think it definitely brings the recreation community to the table. The recreation community is also fairly well represented by a lot of NGOs, Trout Unlimited, and other groups. So their voice is I would say quite strong. And it's an interesting dynamic to watch. I think it allows certain actions to be taken here in Montana that maybe elsewhere is a little more challenging because there is that set of priorities that's quite strong.
Thanks, Jamie. Do we have anyone else wanting to ask a question or comment? Okay, yes. Bo, do you want to ask this question? Oh, no. No, yeah, you sound like a chipmunk. So let me read Jamie the question. Thank you for asking this question. So Jamie, it's what are current or potential methods of monitoring of beaver mimicry effects, such as observing partially submerged vegetation soil or identifying different types of vegetation soil generated by the additional water? Also, what are ways of determining whether groundwater recharge happens due to the proposed initiatives?
Yeah, that is a great question. Thanks, Bo. It's also probably better answered by an actual hydrologist. If there's one here, I don't know how much Sarah knows about this, but I know there are I think they're called piezometers that actually measure groundwater level and groundwater change. So the kind of gold standard, as I understand from my hydrologist colleague, Rob Payne, who is doing this, is to do a pre and post study. So before you build the beaver mimicry structure, you would have some data on groundwater levels using, I hope I'm correct in saying a piezometer. And then you would—
Piezometer, yeah.
Okay, good.
You got it.
And then after the beaver mimicry structures put in, hopefully at least one season or multiple seasons of measuring. Also NDVI, so the vegetative index, basically how greened up an area is using remote sensing data. So, before and after the structure goes in. I don't know, Sarah, anyone else have anything to add?
Yeah, I mean, that's definitely the gold standard, like you said, as a way to do it. Mapping the extent of the wetted area, like wetland mapping. There's tons of protocols on wetland mapping, is another common way. But if you don't have any of those things, the sort of easy, cheap way to go is really plant identification, because certain plants can only live in certain water conditions. And so the more water you have, as those plants get, as that land area and the water extent broadens, the species composition will change in the wetted area. And so you can sort of map the movement of the more wetland plants expanding their area out. So that's sort of the easy botany way to show the shift without all the fancy tools.
Excellent. Maria, should we give more space for questions or?
I think probably we're getting to the end of our time here. So I'll just say thanks again to Dr. McEvoy for spending this time with us, and thanks for all of you for being here. We have some other events coming up that are on our website if people want to check them out. And again, I encourage you to get in touch with us, either with Miriam or myself, if you have thoughts about projects you'd like to do with us or events you'd like to see us host. Since we're just getting started, we're open to your ideas and input. And this has been a really great session to kick us off, Jamie. So thanks again for your great research and for being here to present it to us.
You bet. Thank you. And it's cool to see the Center for Community Geography doing its thing, bringing together different community members. So thanks for the rich discussion and the invitation.
Yeah, thanks. And just a reminder, if anyone's interested in the thing that Miriam mentioned for next week, Jamie's going to be back visiting one of our classes here in the department, and others are welcome to join. You just have to do the readings. So contact Miriam if you're up for that. And we'd be glad to have you join us for that as well. When is it, Miriam?
It's next Thursday, so not this Thursday, the 8th at 4 p.m.
All right. So if you're up for that, just get in touch with us.
Mm-hmm.
All right.
Okay,
Thanks,
thank
everyone.
you so much.
This recording will be posted, so you can check it later if you want to refer to any of the slides, or if you want to send it around to others. That will be available on our website later.
Bye, everyone. Thank you.
Thanks, everyone. Thanks, Jamie.